This is a warning. Bentley went ahead and made a video far too long than a normal math video, so you may want to go to the washroom now, perhaps splash some water on your face, and then return knowing what you are about to face. 22 minutes of video. Good luck. Alright folks, we have a lot to talk about in this video, and the first thing I just want to quickly review is how to find the slope if you're given a table of values. Okay, we did do this in one or two videos earlier, but I just want to look at it again. It looks a little confusing this time because this table of values is horizontal. Do you remember the last one we looked at had x and it had y and then stuff there and stuff there? Well, same thing, it's just sideways this time, and notice x and y are a little different here. So if you remember slope, and it can also be called the rate, and sometimes the rate of change or the constant rate of change. These are just different words for slope. Remember, it can be found by finding the first differences. So you take the number here minus the number here, and you get a number here. Then you take this minus this number, and you take the two numbers that you get each time, take this number and divide them. You get the slope. Okay, well, enough talk. Let's actually try that here. Let's start with the y values, okay? Just like we did before, we started with the y in the last video. So what's 5 minus 2? 3. What's 2 minus negative 1? Well, you can do it on your calculator or just think about it a little bit. You get 3. Okay, so our rise, remember the y values are talking about the rise. The rise is 3. What's the run going to be? Well, 7 minus 2 is 5. 2 minus negative 3 is 5. So the run is 5. So our slope in this situation is 3 over 5. Can that be reduced? No, it can't. Do we have to worry about a positive or negative here? No, we do not. Okay, there's our slope, or our constant rate of change, or our rate. Just depends on what the question is, how they're trying to fool you. All right, but don't be fooled. It's just different words for the same thing. Okay, we're going to go to a question now that has to do with a kayak company. It says there are two kayak companies that rent kayaks. One charges $12 an hour, and the other charges $8 up front and $6 an hour. Okay, here's our little picture of a kayak dude over here. Watch this. You ready? This is exciting. I bet you never thought math videos could be that exciting. Okay, well, we won't even bring that up yet. Okay, so we've got two companies. First of all, alright, let's just talk about the first company. It charges $12 per hour. So would you agree that the $12 depends on the time? So time is independent. It's going to go on the x-axis, okay? So time will go here, and the money will go here because money depends on time. Remember that? Dependent, independent. Okay? Now, x is the independent values. So let's make a table of values and quickly figure this out. It says one charges $12 an hour. Let's try and graph this, but let's just start by doing a table of values. So generally with time, it's good to start with 0 before any time has passed. How much is it going to cost when you don't go kayaking yet at all? Well, it'll be 0. Okay, they don't charge you unless you go for an hour. So after 1 hour, it's $12. 2 hours, $24. 3 hours, $36. Notice each time here, to get from 12 to 24 to 36, I'm just adding 12 each time, or that's really our first differences. And over here you could say, well, to go from 1 to 12, all we're doing is multiplying by 12. 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. So if we had to graph this situation, and I'm going to bring up the graph right here now. Here we go. Oops, what did I just do? Let's try bringing this whole thing. Wow, I thought this whole... There we go. Interesting. I'm going to have to see if I can figure this out here. Come on. There we go. Cool. Okay. And we need this writing disappeared here. All right. So I've got a convenient graph sitting here. And we've already graphed a few things. So let's see. We just said that if you don't kayak at all, they're not going to charge you anything. If you go for 1 hour, it's going to be 12 bucks. 2 hours, $24. 3 hours, 36. Of course, it just keeps going. 4 hours, $48, and it just keeps going up. Okay, I'm going to even draw a line here. All right, it just keeps going. It depends how long you want to kayak. That's a pretty long trip if you're going for 4 hours. It's actually a lot of hard work there. Okay, so in this particular lesson, I'm going to shrink this down, and I'm going to move this. I'm going to move this over, if I can. There we go. I'm going to move that over. Let's just not even look at the graph right now, and let's just think about something that is a little bit different than we've talked about so far. I want to come up with an equation so that if I asked, an equation looks something like this. Y equals, so in order to find the price, we're going to have to times x by something. Well, x is the time, okay? And how much does it cost per hour? Well, it's $12 per hour. You don't have to use y and x if you don't want. You could say the cost, C, is equal to $12 per hour. But this, or you could say this, these two equations, they would just give you whatever price you're looking for. If I said 5 hours, I would just go, oh, that's easy. C is equal to 12 times 5. And that's 60 bucks. Okay? So you could quickly find out. If you didn't have this chart here, a chart is a nice way to do it too. You'd say, oh, 5 hours. And if you could go up here, you'd see it hits $60. But anyway, this equation actually works really quickly. But I want you to notice the significance of that 12 there. What is that 12? When you look at this table of values here, okay, I'll make it a little bigger just so you can see it again. If you look at that, or if you look at this graph over here, what is the significance of the 12? We know that y is the cost, or c is the cost. We know that x and h are just talking about time. But what is this 12 in this equation? Well, let's look at table of values first, since you already know how to do that. Pick a yellow one here. Let's find the slope. What's 36 minus 24? That's right, it's 12. 24 minus 12? 12. Okay. Do you remember how to find the slope? Well, 3 minus 2 is 1, 2 minus 1, there's 1 each time. So the rise is 12 right here. The run is 1. So our slope is 12. That's kind of the answer I wanted you to see. I wanted you to notice that that 12 right here is our slope. And actually, it works really nice to use the word rate here, because we use that word in real life sometimes. What is your rate per hour? 12 bucks per hour. Okay, so the rate and the slope are the same thing. Rate actually is a nice word to use here. Okay, 12 bucks. $12. And remember, if you wanted to find it using this graph over here, you would just make a little triangle here, like that, and you'd say, what's the rise between here and here? is 12. What's the run between here and here? 1. Okay, rise over run. The slope is 12. You could use the graph or the table of values. But the important thing is here is that this 12 is the slope, or the rate. Rate of change is another word they sometimes say, okay? One last thing to say about this particular graph and this particular situation. Remember from the past, if I asked you, can you tell me one more word to label this situation? Well, if you remember, this is called direct proportion or direct variation. Okay? This is a terrible color to write with. Direct variation. Okay? That is just a label for a proportion like this situation that starts right here and goes upwards from there. Okay? If it started from anywhere else, it would be called a partial variation. Okay? It's just a word that's important. If you go on and do like the EQAO, they're going to ask you stuff like that and you're going to have to know it. Okay? So speaking of partial variation, let's look at the second company. Hint, hint. So one more time, do you want to see this kayaker go across the screen? You're getting a little tired. It's been a long video. Okay, this will perk you up. Ready? I bet you're ready to rock now. Okay, in this situation here, let's go a little quicker this time. I won't bother with the table of values. I'm just going to go really quickly. The other company charges $8 up front and then $6 an hour. So they charge $8 no matter what, but they also charge you $6 per hour. Okay, can we just make an equation here? Well, all you really have to do is just put a C here for cost, and you've got $8 and $6 per hour. Let's see if this works. If you go for 0 hours, notice where the H is, I put a 0. 6 times 0 is 0. So if you go for 0 hours with that company, it's going to cost you $8 because you agreed to rent their kayak. That's $8, please. So $8 no matter what. Doesn't sound like a very good deal, but chances are if you rent it from them for a really long trip, it would actually be cheaper in the long run, but you might not realize that yet. Okay, if you went for 5 hours, 8 plus 6 times 5. 6 times 5 is 30 plus 8. That'd be $38. Anyway, here we have an equation, okay? C equals 8 plus 6H. Most textbooks, you can write these two things in any order you want. You could put C equals 6H plus 8 if you wanted to. It doesn't really matter. For some reason, I prefer to have this up front and the 8 over here. Now, I want you to remember something from the last video. Do you remember that this number, this coefficient in front of this variable h is something special? Do you remember what it was? If you remember from the last video, you'll say, hey, that was the slope. So let's see if we can figure out what the heck this 8 is on a graph. Let's see if we can figure that out. All right, let's bring up our graph. Oh boy. Let's see if I can get it. Come on, graph, you can do it. Yes, okay. It's coming up. Why not just go like this? Why go all the way up there? Okay, can everybody see our graph? Very good. Okay. So, we have, get our pen ready. Let's use red. Okay. If you agree to rent a kayak, you agree that it's $8 no matter what. If you go for 0 hours, it costs $8. If you go for 1 hour, how much does it cost? Well, it costs $8 plus another 6. What's 8 plus 6? 14. Okay? So remember 14's right here. Okay? If you go for 2 hours, how much is it going to cost? Well, 14, but you're going to have to add another $6 each time. So that's 20. It's going to cost $20 for 2 hours. Okay? And it's going to keep going like this. Okay? 3 hours is $26 right there. Okay, and I'm going to connect the dots just like we did before. Now already, can you tell me what kind of graph this is? I'll give you a hint. Is it direct variation or is it partial variation? You should be telling me this is partial variation. I'll just go variation. The reason why is this graph does not start down here. It starts right here. It starts anywhere but 0. It starts up at the 8. So that's the definition of a partial variation. It's also a linear equation because it's a straight line. All these words you've learned, hey? We know that the equation is y equals 8. Sorry, it's y equals, what was it again? Up here. 6. Let's just go back here. I'm trying to erase that 8. Y equals $6 per hour plus 8. Is that right? That's right. It's $6 an hour plus 8. So 6, is that truly our slope? Well, if you looked at the first differences here, you'd see these are all 6 and these are all 1. So yeah, 6 is the slope. So this is the slope as we know from before. So what is this 8? What can we call it? This is called the slope. This 8 has a special name, and I want you to know it. Okay, well, you could throw out different words to me. Some students like to call the 8 the start, or the starting point. Because look, it is starting. It is starting right here. Okay? Certain mathematicians call the 8 the y-intercept. Some mathematicians, and actually a lot of people, and they want you to know this word too, they call this 8 the y-intercept. Now, this is the y right here. The y-axis is right here. The y-intercept is the place where our equation, our line, crosses the y-axis right here. Okay, that is called the y-intercept. So, let me show you this. There's a special name when you have y equals the slope, and I'm going to put, instead of a number there, I'm just going to put the letter m. That's the slope, followed by the x variable, plus, I'm just going to put a b here. The number on the end is called the y-intercept. Okay? I'm not going to write the whole thing out. It's a big word. And this whole thing, this form, when you write an equation that has something and then an x plus a number, is called the slope intercept. I'm going to write the whole word intercept now since this is a new word. Slope intercept form, or slope intercept equation. Okay? And they often use the letter m for the slope and the b for the y-intercept. Okay, this has been a pretty long video. You've hung in there really well. But just to make sure that you were listening, if I show you this, y equals 3x plus 5. If I asked you what's the slope, you should quickly say slope's 3. If I say what's the y-intercept, you should say it's 5. If I told you to graph this thing, if I told you to graph it, you could just draw one of these and say, okay, y-intercept is 5. 1, 2, 3, 4, 5. Put a dot right there. Is this graph going to rise or is it going to fall? It's going to rise because there's a 3 there. So the rise is 3. By the way, it's invisible, but 3 is really 3 over 1. It's really the same thing as saying 3 divided by 1. Because we want to rise, we want to run, and it wasn't showing any run. So, and we don't want any bad jokes about runs here. And so anyway, 3 over 1. 1, 2, 3 up, and 1 across, right there. And this graph is going to go this direction right there. We've just graphed it. Okay? So, let's try another one. Y equals negative 2x plus 4. If I said to graph this, you'd say, this is easy. All I have to do is go like this. 1, 2, 3, 4. Put a dot. That's my y-intercept. I'm done that part. Do that part first. Negative 2. That's the slope. It's a negative slope, so it's going to be going down. But I want the rise and the run. I don't see the run here. Well, all you do is put the number over 1. Negative 2 over 1. So you go, instead of up 2, go down 2 and across 1. And then connect the dots, just like you did when you were little. And there's our graph. Okay, see how quick this gets if once you figure this stuff out? Uh-oh, we've got a white screen here. You could get an equation like this, y equals 3x, and notice there is no plus anything on the end or minus anything on the end. If you wanted to, you could say it's a plus 0 on the end, but really, all you need is this showing in order to give you a graph. And whenever you don't have anything on the end like plus something or minus something, it's an example of direct variation. So it's going to be a line that, well, in this case it's a positive slope, and it's going to be starting right here. It's going to go up 3 and across 1. So it really, I guess, could be like this. That's called direct variation, and that's what this particular graph would do. Y equals 3 over 4x minus 5. If you had to graph this, what would you do? Okay, this time I'm going to go like this and say, okay, start with the y-intercept. 1, 2, 3, 4, 5. There's our first dot. That's the y-intercept, it down at the negative 5. Now it says 3 over 4, so that's 3 up, that's our rise, and 4 across. 1, 2, 3. 1, 2, 3, and 4 across. 1, 2, 3. 1, 2, 3, 4. We've just graphed it. I don't know if you realize how much you have done in this video. You may want to restart it. You may want to throw the computer out the window right now. But we have pushed through a lot of information here. You figured out what the slope intercept form of an equation is. And we're even talking about how to graph it. But I just wanted you to see how quick it is to do this stuff. And hopefully I'll find something at Khan Academy or something so you can practice this now, because that really is what this is all about now, is just practicing, okay? Whew. This is the longest video of the bunch. Congratulations.